Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
In 1989, I discovered how to harness a new global network of 64 binary thousand processors and how to use them to solve the toughest problems arising in STEM fields. I was able to make my discovery of practical parallel processing and do so because I visualized my ensemble of processors as evenly distributed around my globe that I defined in 16-dimensional hyperspace. I visualized each processor as separated by equal distances from 16 nearest neighboring processors. For planet Earth, that has a diameter of 7,917.5 miles, each of my 65,536 processors would cover an area of about 3,000 square miles. I metaphorically visualized that new supercomputer that I used to experimentally discover practical parallel processing. My metaphor for my new supercomputer was a cube in an imaginary 16-dimensional universe. I visualized supercomputing with 65,536 central processing units that I visualized as evenly distributed at each of the 2 raised to power 16 or 65,536 vertices of that cube that I visualized in 16-dimensional hyperspace. I visualized my 16 pairs of bidirectional email wires as emanating from each vertex of the cube and in the 16 perpendicular directions, that is along the 16 edges that emanated from each vertex. For that specific configuration, my parallel processing ensemble had 1,048,576 short email wires that I visualized as uniformly distributed on the surface of a globe in a 16-dimensional universe. The parallel supercomputer wizardry that made the news headlines back in 1989 was that I parallel processed across a new internet that was a new global network of 65,536 central processing units. In effect, I parallel processed blindfolded and did so without seeing any of those processors with my naked eyes. It was for a good reason that I parallel processed alone. Back in the 1980s, the reason was that parallel supercomputing was then dismissed as impossible. Please allow me to put the parallel supercomputer in the perspective of the 1970s. Back then, solving a grand challenge problem and solving it by dividing it into 1 billion smaller problems and solving them while maintaining a one problem to one processor correspondence and doing so with 1 billion processors was a very terrifying thought. That was the reason no sane supercomputer scientist attempted to solve the grand challenge problem. That sense of foreboding prompted the Computer World magazine to carry a negative article on the future of the parallel supercomputer. That article was published in its June 14, 1976 issue and was titled, quote, "Research in Parallel Processing, questioned as waste of time," unquote. In the 1970s, to parallel process through invincible 2 raised to power 16 or 65,536 central processing units that encircled a globe in a 16-dimensional hyperspace was like searching for 2 raised to power 16 black boxes that were equal distances apart and on the surface of a globe that was in a dark 16-dimensional universe. I had to visualize the exact locations of each and every central processing unit that I must parallel process across before I could harness that processor to solve a computation-intensive grand challenge problem. As the first and the only full-time parallel processing supercomputer scientist of the 1980s, I had no competitor when it came to giving lectures on how to solve 1,000,000 problems at once or in parallel. In the 1980s, a pattern of invitation that was followed by disinvitation emerged. In the United States, I will be invited to give a seminar lecture on a parallel supercomputer and invited by telephone. When the seminar organizers discover that I am black and African, they will find a pretext to disinvite me from delivering my lecture on the massively parallel supercomputer, even though I was the only person in the world that could teach them how to solve a grand challenge problem and do so by chopping it up into 1,000,000 smaller problems and solving them with a 1 problem to 1 processor correspondent mapping. After several disinvitations, I learned to disguise my identity as a black African and pass as a white person in the field of supercomputing. For that reason, many supercomputer scientists of the 1980s thought that I was from Eastern Europe and presumed that I was white, and were shocked when they met me on February 28, 1990 in San Francisco, California, the date and place I was awarded the top prize in the field of supercomputing. The IEEE committee that gave me the top prize for my contributions to practical parallel supercomputing would have revoked that prize if they had discovered before the award ceremony that I was black and African. Everybody was shocked when I stood up to receive that supercomputer prize. That prize is won by a team of up to 50 supercomputer scientists. I am the supercomputer scientist to win that prize alone. Thank you.
Insightful and brilliant lecture.